Well, happy Thanksgiving. If I were explaining inflammation to my grandma that I knew best, her name was Naner. She actually had rheumatoid arthritis. But if I were explaining inflammation to her, I would start by just asking, what is inflammation? Well, inflammation is the body's set of coordinated responses to any type of tissue damage. So it could be tissue damage from the outside, like I stepped on a nail, or it could be tissue damage from the inside, like I ate a food I'm allergic to. And inflammation can actually be harmful or helpful to the host. I'm the host in this case because it's my body, and so I'm the host. Inflammation is beneficial in the short term when it can solve the problem, but if the inflammatory response goes on too long, like in rheumatoid arthritis, diabetes, inflammatory bowel disease, or if it's too strong, like an anaphylactic shock, that's when we have trouble. The main signs of inflammatory response are redness, caused by extra blood flow in the area, heat, which is the increase in temperature, swelling or edema caused by accumulation of fluid in the tissue, and pain. Inflammation can be initiated several different ways. Our cells have what are called pattern recognition receptors that can detect bad guys, basically. They're like scanning for a certain code that says, I'm a bad guy, and if they find a bad guy, that's going to initiate inflammation. The presence of microbes or certain cytokines, which are chemicals that our bodies produce to initiate inflammation, that will obviously initiate inflammation. Release of inflammatory markers or chemicals, especially cytokines, will do that. Some of the cells that release cytokines are monocytes, macrophages, and lymphocytes, which are some really cool names for immune cells in our bodies. And recruitment of white blood cells such as neutrophils, eosinophils, basophils, and mast cells also will initiate inflammatory response. So we talked about cytokines earlier, right? Those are those chemicals that our bodies produce. How can they have a systemic effect throughout my whole body? Well, the way that works is because of something called signal amplification. That's basically where one cell produces cytokines, and some of those cytokines meet up with another cell and cause that cell to produce cytokines, and then those cytokines cause more cells to produce cytokines. So basically it's like a domino effect, getting stronger and stronger, and that's how your one cut in your maybe the nail you stepped on with your foot can get that signal throughout your whole body. It doesn't mean that inflammation is going to be throughout your whole body, but in some cases we can get a whole system effect. The thing that causes inflammation to resolve is when the causing factor for the tissue damage is brought under control and the inflammatory response is able to lessen and go away. However, if the nail is still in my foot, then the inflammatory mechanisms have not been able to eliminate the tissue damage, the recurrent infection or whatever, and that's going to continue to cause inflammatory response. Inflammatory responses can be regulated by something called cytokine receptors. Cells in our bodies that need to respond to a certain cytokine, which is those chemicals, they're designed with a receptor for it. So depending on the quantity and the identity or the type of cytokines that bind to a cell, those cytokines can initiate what's called upregulation, which means, increase the interaction or the process, or increase that response. Or it could be a downregulation that says, hey, decrease this response. We don't want any more of this. So cells are designed to be able to respond in different ways to different cytokines, different quantities and qualities of cytokines, or even a combination of them. The conclusion is that although in the long term inflammation can be damaging if it's too long or too strong, all in all it is designed to keep us safe from a lot of different short-term threats in our bodies. So happy Thanksgiving and thanks for listening.